Okay, hello Dr. Hanai. Here's my final presentation for the SURF project presentation next week. So what I'm doing here is remote solar energy generation for electric ASVs for ocean-based applications. What I mean by that, ASVs, autonomous surface vessels, essentially autonomous boats that can travel on the ocean. They're deployed globally. They're pretty much everywhere. They do everything from surveying to I know the U.S. military uses them to assess threats and use their own neural networks to, detect enemy ships. They can be used, yeah, like what I said, just for research or maybe just for picking up ordnance inside of the ocean. So like if a rocket explodes and there's floating bits, we can quickly send an ASV, or there might be an ASV in that area that can go help someone out, or potentially just grab the payload that exploded in the air, something like that. Well, the problem with that is that these vessels run on batteries, and the batteries need to be recharged. So what I'm proposing here is a somewhat clean energy, apart from generating the batteries and generating all the components, the electrical components and the copper to create this. But what I'm thinking here is it's a deployable PVC, inflatable PVC deployable perovskite sort of floating raft per se that gets deployed, and you have a battery that attaches to it that maybe you go underneath and you attach it, then you deploy the raft. So you inflate this, and the beauty about inflating it is that you can roll it up. So now you can roll it up really tight and put it inside of a shipping vessel, so it's not this massive piece, massive, like essentially square box that you just deploy. So it's a smaller piece that you can inflate or put it on a ship, roll it on the ocean, inflate it, boom, now it's set up. Hook up your wiring. So by integrating high efficiency perovskite cells, which are, they're still being developed, but if this is the case, then we can weave them directly on. So we're not worried about like loose panels, especially in rough seas. Water can just go straight over it. It's essentially a waterproof floating raft that we've used for a long time now. That's inflatable PVC. This allows, and then you have a setup right next to it that allows autonomous vessels, so the ASVs, to dock, and they can recharge. So, essentially an ASV can go out and recharge using this floating raft. Now, I did my testing using the generative AI models on a smaller raft, which is about 12 foot by 12 foot in size, just as an example. This was off the coast of Waimanalo Bay. And we were able to yield approximately, according to 22% efficiency ratings on these cells, 105.22 kilowatt hours per day, which is fairly good considering that there's no overhead, there's no AC to run or anything. You're just charging a battery. So the batteries in these ASVs vary, so it's kind of hard to quantify how many of them they could charge at a time and how long the recharge time will be, because that's dependent on battery cells. Future work and the conclusion of this idea would be that, the manufacturing of the perovskite cells is still kind of theoretical. University of Sydney has done some great work, especially in 2024, where they're able to make a triple junction cell. And they built it on a piece that was about 16 centimeters squared. So it's still quite small, and we don't really have any facilities to manufacture something at this scale, but hopefully in the future that will be the case. Or that would be a solution. And the other factor of this is the battery cell. So battery cell technology is continuously improving, but how do we keep it cool? So I'm thinking maybe for future work, it could be underwater, where the water is relatively cool, and the heat transfer between water is so much better than air, and it's not directly in the direct sunlight. So you can keep the battery cells somewhat protected, but then you have the risk of corrosion. So how do you prevent that? My references are here, and my acknowledgments are you, Dr. Hanai, the Aladdin CAD and simulation software we use this semester, and Capilani Community College. Thank you.